Welcome to the Destiny of Manufacturing podcast, powered by the Precision Metal Forming Association. I am your host, Dean Phillips. It is great to have you here today. I have my guest on here who is, from Co. Press Equipment, Reid Co. Welcome, Reid. How are you, sir?
I'm doing well, Dean. Thank you.
So right off the bat, tell me about your big takeaway of where you think we're going to be 5 years from now in the destiny of manufacturing.
Well, I think 5 years from now, I'll do a reality check and then I'll do a dream. The reality of what I think is going to be happening is, we discussed that there was hubbub of other technologies and other types of transportation that would be hitting the industry. It's not moving as fast as they had thought. There are different technologies that haven't been developed yet, namely battery storage devices that have a high energy density. And so I'm not seeing a lot of the different battery assemblies gaining the same traction. So I think what we're going to see is fighting for uptime. I think we're going to be fighting for what people like to say OEE 80% or 75% is the industry standard, but if you really look at people's numbers, as you know, they're usually not even close to that. So,
right.
And the technologies to get us to that 80, I think, are much more affordable, and we have much more predictable results with the experience we've gained with these sensors. So
That's a great point. And I think the payoff for adopting technology is there. It's proving to people that you can get there with those technologies.
Right.
Like IoT. We've been gathering data for decades now of big data. Well, big data is only valuable if you can act upon it.
Yeah.
Years ago, I had an engineer that was going to put hour and minute and second meters on all of the machines, on all the presses, and then go around and write down how long they were running while they ran. Well, so what? It only matters if you know what that means. If it didn't run, was it supposed to run? Was it setting up? If you can't apply that information and act upon it, it's not very valuable.
Right.
And I think that's we've got to the point where we're gathering good data. We're starting to understand it, but we're still struggling with correlating it between different things.
Right.
How do you see technology impacting the average stamper? What do you see coming down the road?
I see the costs for automation coming down significantly, and that'll bring the price of the equipment into their perceived ROI. I say perceived because people have these numbers where they think the machine needs to be for it to be worth the larger investment. And that's been the biggest thing. I know you and I before this spoke about the juxtaposition of the smaller stampers that need everything they can get to fight the big stampers, but the big stampers are really the ones that invest in technologies, and the small guys invest in the very lowest in automation typically.
Right. And that's a challenge, I think, to compete with companies like a Toyota.
Right.
So Toyota has gotten to the 5-minute changeover. But one of the things that makes that possible is all the technology. It isn't just one piece. It isn't having a press control or some technology like that. It's also having rolling bolsters, having automatic coil changeover systems. It's having all of that. It's not one phase.
Right.
And I think that people think you can't make small incremental improvements, but I think time has already proven to us, when you think about, let's use high strength steels as an example. When we look at how high strength steels were before to where we are now, when they were first coming into the marketplace, people were having a terrible time because number one, they probably weren't ordering the correct rolls from you.
Yeah.
And they didn't have the right drive for high strength materials.
Right.
So have you seen that becoming more and more prevalent where people understand more now?
Yes, I have. You know, the biggest thing too is the accountability that you can hand back to the mill on the quality of the result is starting to become more precise as well. Meaning, you know, deviations via crossbow or edge wave or camber, these types of things are starting to become less prevalent in your sub 100,000 KS or 100 KSI excuse me, materials. Right. So I think that, and those materials are starting to come down in price as well. You know, once someone told me that with all the recycling that's going on, the base level for a mild steel has actually come up, I think, 5 to 10 KSI. Now, obviously, you can go down and get, you know, different certifications that will hit your yield range, but the hive mind of stamping sees a 50 or 60,000 KSI PSI coil as the norm. In the past, something like that was high strength. You know, 40
right
KSI was kind of the mild steel and what people would stamp.
Right.
And so because of that, you take away kind of the mystery behind it, and people can predict it a little easier. The consistency of the material coming out is improved, and so we are able to then process that with more repeatability. And so with that, now, you know, sensors that we would have used before needed before, because you would have these deviations and being able to tell the press and, you know, anticipating this material hitting the press. And now we don't need those. Right. And I think, you know, with the biggest thing too, we talked earlier about was the fact that these sensors are getting so much more cost effective. A package that we launched 10 years ago now is going to be in our base model. So it's, you know, what we had a technology called Work Roll Advisor where it would actually automatically, based on the yield strength, the width, the material type, would adjust, and the work rolls, and it would adjust them automatically actually as the work roll, as the the coil pays off, because your coil set changes.
Sure.
It's a tighter radius, right? So that was, what's that? I'm sorry.
I was gonna say it's interesting that you say that with how you're able to do that now.
Yeah.
Do you find that people don't understand things like taking the yield out of the material, so that, you know, if you don't set your rolls properly or you don't take that out, it makes it more difficult to form it once it gets into the die, and people don't often understand some of that value. Can you expand on that a little bit?
Right. Yeah, I mean, flat isn't stress relieved, and a lot of times people fight for getting flat material, but what they don't understand is that, you know, a lot of times in this industry, you have these segmented groups. You have your equipment suppliers, you have your operators, and then you have your die makers and your die shop, or your die room in the shop. And because we all use different language for different things, we call coil reels. People call them decoilers. People call them mandrels. Coil cars are called coil carts, and all sorts of things, right? Mm-hmm. So because we use all this different language, and because we are somewhat isolated as groups, it's hard for us to translate what we found to every group and have it be successful, because we can tell an operator till we're blue in the face, but if the die shop doesn't change the die, or at least they think flat material is stress relieved and now they're changing the die, and then we give them the right settings and then they're off again. That happens all the time.
Right.
You keep moving in a circle, and I think that's the biggest thing that we could get through. And you mentioned education earlier. I think it's a big thing.
Absolutely. And I think a lot of times people don't understand too. If you hit a hard spot in the material, it wants to pull that material in a different direction
Right.
as it's going through the die and as it's going through the rolls. And it takes more technology wise for us to understand that. I think everybody would be better served if they made a trip to a mill or a slitter and
Absolutely.
understand what that is, because we experience it all the time and understand how much material means to a good quality part. But I think a lot of times people just assume it's good, that the material's the same. It doesn't matter
Right.
from one coil to another, but it
Right.
isn't.
Right.
And there's so many things that they could do if they understood the process a little bit better and they understood
Right.
the materials.
Right.
When you're slitting it on one end of the coil or a different end of the coil. That's going to come out very different on how the thickness is and the hardness. And then even in the center, getting that camber in there and wanting to twist when it actually hits the die.
Right.
Those are some challenges that we have. Do you see AI as having a place in some of this?
Yeah, AI has a huge hand already on being able to write software. Now, I don't know what it looks like with ladder logic and the types of, just say like an Alan Bradley type programming strategy. I don't know if it has that ability yet, but it's easily trainable to be able to write software. So when we do come to conclusive decisions on how to have, let's just say, transfer arm pick up that part, to tell it what to do in the program, I think is going to become relatively easy. I'm not sure how far away we are from that, but I think that's going to be that's going to be the tip of the AI spear. I don't think it's going to take over human or public relations as much as people think it will.
Right.
And you had mentioned earlier, using AI to collect and organize data tables. That also is a really good application of AI. But it'll be interesting to see how it manifests.
Yeah, you see more and more automotive companies starting to adopt these AI systems for analyzing data that
Right.
they don't, it isn't automatically correlated. So they're gathering things like the current of a motor, the
Mhm.
temperature of a bearing, the pressure that's being produced, tonnage or other things like that, and vibration. So as all of those start to correlate and have a problem, as a bearing failure might show you, you're getting more chatter from the bearing. It's got more friction and the current goes
Sure.
up. So now
Right.
you could correlate it, but it has to be correlated data. It can't just be two things that are coincidental, because sometimes that
Exactly.
can happen. And then
Right.
is something a cause or an effect,
Right.
which is happening here.
Right.
And I think when we think about data, we've been gathering data for so long. It seems like for decades we've been gathering it, but how much value does it add if we can't act upon it? You have to be
Right.
able to use that data to go out there and be able to manifest the changes.
Right.
I use comparisons all the time of companies that were gathering data, new problems that they'd had. It's like walking out in a plant and you see the roof leaking. Well, hey, the roof's leaking. And well, the people that have been there for a while, they just walk around it because they know that the roof leaks. They know it comes down, and they know that they put a bucket there. They just walk around and they don't even see it anymore. They don't even see these problems
Right.
because they just experience them all the time. So they can't even see it. So sometimes
Right.
fresh eyes and data gathering can really help us with that.
Right.
Now, when you think about workforce and the technology where it meets, what do you see as some of the bigger challenges we have of educating some of the workers? Because we're already have lost a significant portion.
Right.
What are some of the things that we can do to try and make things better or easier for some of these newer workers?
The biggest thing is going to be, we need to, any beautiful technology is very simple, but it solves a big problem, right? And so I think that what we need to do is to build robust, simple automation solutions where, and that's what we're working on right now for our next round of controls levels, to be able to have someone hit buttons, confirm that the machine has done what they needed it to do, whether it's centering the coil, whether it's threading up the coil, whether it's making sure the work rolls are set correctly, and be able to do that cost effectively. Like we were talking about earlier, these types of things are getting to a point where, with the two things, the sensors are becoming more cost effective, and then being able to do IO with the IO link technologies into something that used to have to require terminations and large IO rack provisions. Now we're able to do it with less than a quarter of it, right? So I think that this type of technology is going to take away from something where you'd have a Billy or a Johnny who's known that machine for 20 years and has the numbers written on the side of the machine, and he knows it. No one else can do it like he can do it. That's what's going to change it, and it'll always come down to understanding that flat material is not flat, or it's not stress relieved, and the die team understanding what they're seeing when a part isn't being made correctly. It's always going to come down to that. So, I think if we could invest as a community in understanding material reactions to formability, to being formed, I think that'd be the next best thing beyond just an operator setting up a machine and it doing what it needs to do.
Gotcha. Does this change in technology lend itself to where small companies can reach what large companies can do? I know if you look at things like, for instance, drone technology and 3D printers, the same technology that we used to use a decade ago that in order to achieve that was millions of dollars.
Right.
Now we can get that in a few $100 package.
Right.
Do you see smaller manufacturers saying, yeah, this is something we can invest in? Automation,
Yeah.
you think about robots now even,
right.
But on your side, on the automation side, is that something that you could see where people would say, yeah, I can make that investment, but also add value?
Right.
It has some ROI to it also.
Right. I do. I think, the thing is as an industry, there are too many norms. So there are too many standards, meaning, one company that will provide something to, no, that has to be an absolute encoder. Another one, no, it can be a resolver. So the problem is that, to answer your question, yes, but we all need to start to come to some standard consensus. In the 3D printer world, they have made their way with stepper motors, very simple stepper motors. And obviously, I bought a 3D printer for it. I also started a company about 3 years ago, a second company. And, I just quickly discovered that you can't stop a print and then restart something on top of it, or even have like a print fixture, right? Because you have to do support. And it was so weird to me because in the CNC world, fixtures are no big deal because you have servo motors and probes that'll pick up your part. but the reason why these technologies are so cheap is because they don't have that type of accuracy, right?
Right.
So to answer
Well,
your question, if we can find and define the areas that do and don't need the accuracy, that's when we can really pull a lot of money out of these machines. You know what I mean?
yeah,
Um,
yeah, absolutely.
we're coming out with a series called the Flattener series. So we're backing off the precision and the range of a precision straightener. And what that's going to be is a much lower cost. You only need to get it flat type of a material, low yield stuff, so that people don't have to buy these higher strength straighteners that everyone has kind of converted to. And I think
Right.
that type of market focus is really going to give people an advantage in specializing. So, but anyways,
Gotcha.
yeah,
Yeah, no, I think that's tremendous, because having the ability to reach those goals for the small to mid-sized companies is that's what we're all about with the PMA
right,
and the majority of companies that we deal with.
right.
So with that said, where are we now with your reason for being part of the PMA?
So, my reason for being here is because I believe that communities share each other's load, and that's how we're going to grow, is as a
Mhm.
group. I'm extremely proud of David Klotz and the job he's doing as the president in the PMA. Uh, he has been incredible to work with and has really involved me. So he's a big reason why I'm here as well. And I would love to see us start to shore up language so we're speaking the same thing. And the only way we can do that is through a group like the PMA. The PMA is the biggest group. They advocate for us in Washington. So that's why I'm a part of this group.
Absolutely. Yeah. And it's great to see a community and building a community around
Right,
manufacturing, and especially something specific to our industry, metal
right,
forming, and which is difficult, because I
right,
think in general, our industry is drug kicking and screaming into the future for many
right.
reasons over the years. So our embracing of technology has to happen and
Yeah,
take a different approach to it. What do
right.
you think about, where do we need to be in this now?
Um, just concerning the technology and where we're going. Is that what you're?
Yeah, we've kind of adopted other industries'
Right,
technology.
right. Yeah, I would love for us to I would love for us to, for a long time, we've been dragging our feet because people just want to do it the way they did it. And the problem is when I started here, for our machines, the adage was, we just get the material into the press. We're the necklace around the beautiful lady, right? And the press was the beautiful lady. And I think that if we start to see each other as hands, feet, that we're part of one body, and then as we group together, we can start to create technologies that are world class, that are brand new technologies. And I would love, with the power of the PMA, see us be able to do that.
Yeah, that's a great point. And I love your analogy there, because I think that it does explain it to how people look at us, as we're not
Right,
just an accessory, we are part of it.
right,
Uh,
right.
we're an
No, it's great.
actual appendage for it. So, well, that's
Exactly.
great. Reid, thank you so much, sir. I really appreciate
Absolutely.
you jumping on here today.
Yep.
Again, Reid Coe from Coe Press Equipment. How can people reach you, Reid?
Via email. All my contact information is on our website.
Right.
And so it's really easy to go to contacts, or it might be management or some version of that.
Okay, great. Well, we look forward to seeing you soon. And everybody, we can't do this show without people like Reid being on here as a guest, but also we can't do it without you. So thank you very much, everybody. Make it a great day.